Hello all, my name is Mariam. I did my research at University of Technology in Iraq. Today I'd like to speak about my project, Mechanical Properties of Concrete Contained Ceramic Waste Material. The aim of the project is to minimize the environmental pollution in two ways. First one is using ceramic waste that is stacked in the factories and mix it with concrete, taking into account that my country has a lot of ceramic factory. Second way is reducing cement pollution by reduce our use of it, because as we know, cement combustion accompanied with high CO2 emissions. Also to use that ceramic waste to enhance the mechanical properties of concrete. This is our experimental program, consists of 5 stages, and it's explained by a flow chart as shown. The first stage is to prepare materials such as cement. We used ordinary Portland cement type 1, sand, natural sand with maximum size 4.75 millimeter, gravel, natural gravel with maximum size 19 millimeters, water, tap water. We used ceramic tiles after clean it and fracture it. Then we grind it to ceramic waste powder. We use super plasticizer to increase the workability. The second stage is to make the control mix. We make it to compare between all mixes. We make 3 mixes, and that one helps us to understand the behavior of ceramic. The third stage is to make the other mixes that contain ceramic. First one, a cement replacement, and the second one is the sand replacement. We do that to understand the behavior of ceramic. Is it bonding material as cement or filler material as sand? And this is the method of addition of ceramic waste powder. All 3 mixes have the same mixing procedures as shown. We put all gravel first to get out the dust material, then sand to prevent the adhesion of sand with mixture surface. Then we put super plasticizer to 1/3 of water, then we mix it in the drum. After that, we did a slump test according to ASTM C143 and measure the temperature of concrete according to ASTM C1064. We did a slump test to see whether the consistency of concrete is suitable or not, and the temperature is because when degree of hydration is too high, the conclusion of hydration process are not homogeneous, as shown. After that, we cast the concrete in mold after lubricant it with a little bit of oil. Then we compact it to reduce the air void, which consider as spot weak for concrete. After the mold dry, we put it in the curing as shown. We use water curing, which is help to continue of the hydration process, which help to strengthen the concrete and prevent shrinkage crack. Before our work success, we did this proportion for concrete, but it's failed because there was a lot of super plasticizer and water. So we decided to do a trial mix. as shown. After that, we adjusted the mixture proportion as shown, and we did the control mix. It gave us a suitable slump and a suitable degree. After that, we did the cement replacement. Also, it gave us a suitable slump and degree. But for the third mixture, which is sand replacement, it has no slump. So we decided to increase the percentage of super plasticizer to 1.4% of cement waste, and it's give us a suitable slump and a suitable temperature. The test we did is the compressive strength and the flexural strength. The compressive strength for control mix at 35 days and 94 days give us 47.78 and 49.6. For the mix one, which is cement replacement, it gives us higher compressive strength for both ages because the pozzolanic reaction, which is a reaction between cement and ceramic component with water, and that causes more of gel, which fill concrete voids, and that make concrete stronger, more durable, and more climate resistant. Also for the second mix, which is sand replacement, it gives us higher compressive strength because the ceramic waste powder is very fine material which help to absorb water, and there is some notes I want to take into account that curing played major role in enhancement compressive strength. Also, the temperature had an effect on sample. That's because mix one and mix two has been mixed in different season, and this variation of degree effect on compressive strength and also effect on water used in curing. For flexural strength, we did it also for 35 days and 94 days. For the mixture one, cement replacement, it has no clear effect on flexural strength, but for mix two, it gives us higher flexural strength because the flexural strength depends on the bond between cement and aggregate, and in mix two, ceramic waste powder help in that. For when we did a slump test, we noticed that for mix two, it's the most mix to that absorb water because there is because of the existence of ceramic waste powder to a sand. So there are two water absorbing elements. Conclusion: adding ceramic waste powder as cement replacement increased compressive strength at 35 days, about 10% than control mix at same age, and for 94 days it increased about 19.12 that control mix at same age. Also, it increased for sand at 35 days about 21.5% than control mix at same age, and for 94 days it increased about 28% than control mix at same age. Second, adding ceramic waste powder as cement replacement has no clear effect on flexural strength at 35 and 94 days, but adding ceramic as sand replacement at 35 days increase flexural strength about 7.6% than control mix at same age, and at 94 days increase about 8% than control mix at the same age. Third, adding ceramic waste powder as sand replacement at 35 and 94 days give higher compressive and flexural strength more than cement replacement. Adding ceramic waste powder as sand replacement absorbs more water and it needs more super plasticizer. Also, it released a higher temperature than other mixture. Last, mix 2 sand replacement required more percentage of super plasticizer than mix 1 cement replacement and control mix, which means it's absorbed more water. Thanks for listening.